Okay. Bismillah ar-Rahman ar-Rahim. We'll continue doing these all the exams questions. Let me go back to this slide where what we have. We have, these are the two types. We have infinite integrals. If I have infinity or minus infinity, I need to change that into a limit. And then I need to do the integration and then the limit. So I need to be good in these two things, finding the integral, doing the integration, and also finding the limit. Also, I need to remember the methods we did in Math 101 in finding the limits. If it is from minus infinity to infinity, I will split it into two parts. Minus infinity to a value, usually we take a, and then this a to infinity. This one is similar to this, and this one is similar to this one. Now, if I have discontinuous integrants, if there is discontinuity in the upper endpoint, then I will make it t goes to b from left. Lower endpoint, t goes to a from right. Interior, then I need to split it into a to c, where the discontinuity is at x equals c. And this is, I will make it like this, and this one will be like this one. Then I do the calculation. Okay, let me do examples. Okay, this one, where is my problem? Just with the infinity. So take limit, t goes to infinity, integral 0 to t, dx over x squared plus 1 to the power 3 over 2. Let me do this integration aside, but it seems it will, I will deal with it as an indefinite integral. Clear, it's integral substitution, trig substitution, I mean. I will take x equal tan theta, so dx will be secant square theta d theta. So this integration will be what? Will be secant square theta d theta over, this is tan square plus 1, which is secant square, to the power 3 over 2, so that will be secant cubed. Theta, so I'm getting what? Integral of cosine, and that is sine theta plus c. What is sine? Do the triangle. This is theta. This is tan is x over 1, so it's opposite over adjacent. So this one will be square root x squared plus 1. So that will be what? Sine is what? Opposite over hypotenuse plus 3. Okay, now let's apply this there. So I have limit, t goes to infinity. What will be this integration? It will be x over square root x squared plus 1 from 0 to t. Do the calculation. Limit t goes to infinity. Substitute, I have t over square root t squared plus 1. Zero over 1 is 0. That's it. Now it's a limit problem. Now, if I remember in Math 101 what we did in such case, I will take t squared common factor. I have 1 plus 1 over t squared. There are many methods to do that. Or I can divide by t, but this is also, it will work. T goes to infinity. I have t over the square root of t squared, the square root 1 plus 1 over t squared. What is this? It's absolute value of t. But since t goes to infinity, means t is positive. So I will get rid of the absolute value. That will be t 1 plus 1 over t squared, cancelled. Apply the limit. I have 1 over square root 1 plus 0. 1 plus 0. That gives me 1. So this is my answer. If this integral is equal to 5, find r. Okay. First, for sure, r not equal to minus 1. Why? Because otherwise I will get ln, which will go to infinity, which will yeah, will diverge. So I will do this with r not equal -1. So this integral that will be what? Limit t goes to infinity, integral 1 to t x to the power r dx. And what is that? Since r not equal to -1, I can apply the power rule integration, which is x to the power r plus 1 over r plus 1. From where to where? From 1 to t. That give me limit t goes to infinity, t to the power r plus 1 over r plus 1 minus 1 over r plus 1. Actually, r plus 1 should be negative. Because if it is positive, this will go to infinity. So that will make it, for sure, it will be negative. Otherwise, that will go to infinity, so that will not converge to a value. It will diverge. So if r plus 1 less than 0, that implies limit t goes to infinity, t to the power r plus 1 will be what? T to the infinity to the power negative, t to the power a negative exponent, that will give me 0. So all of this will be 0. So I'm getting what? -1 over r plus 1. And that is equal to 5. Do the calculation. I have -1 equal 5r plus 5. So 5r equals what? -6. So r -6 over 5. And that will be my answer. Okay. Improper integral. Where's the problem? The problem with 0. I have infinite discontinuity. Infinite discontinuity at x equals 0. So what I will do, I will change this into limit. Limit t goes to 0 from right, 0 to 1, e to the power 1 over x squared dx. Now this integral, let me do it in details here. Let u equal 1 over x, du will be what? -1 over x squared dx. So I need minus and minus. So this is my du. So I have what? Minus eu du. And that will be equal to what? Minus eu plus c. And that is minus e to the power 1 over x plus c. Okay, so this integration, now I need the limit, will be what? Minus e to the power 1 over x from t to t to 1. From t to 1. Yeah. So that will be limit t goes to 0 from right, minus e, minus minus, that will be plus e to the power 1 over. Yeah. Now, if you take the limit, note if t goes to 0 from right, be careful with that, 1 over t goes to what? To plus infinity. Why? If you have the graph of the 1 over t or 1 over x, that is the graph. So as t goes to 0 from right, the function is going to where? To infinity, plus infinity. And that implies e to the power 1 over t will go to where? Also plus infinity. If you think about the exponential function, this is the exponential function. So at t goes, as the argument goes to infinity, the function goes also plus infinity. So this is will be minus e plus infinity, and the answer is infinity diverges. That's my answer. Okay. This one, same idea. Where is my problem? I don't have a problem with the 0. Actually, this one is 0. That implies x equal -1 over 5, which is not there in this interval between 0 to infinity. So I need to care only about the infinity. So that will make it limit t goes to infinity, 0 to t, 1 over 5x plus 1 to the power 5 dx. Now let me do this integration here. It's not difficult, but sometimes it's good to do it this way. So I let u, especially if you have something like this, to be sure about the fraction. Du will be 5 dx. So I need 5 and 1 over 5. So that will be 1 over 5 du, or let me say u to the power minus 5 du. And that is what? 1 over 5 minus 1 over 4. U is minus 4 plus c. And that is minus 1 over 20. It's minus 1 over 20. 5x plus 1 to the power minus 4 plus c. So this one will be limit t goes to infinity of what? Minus 1 over 20. Let me make this here. 5x plus 1 to the power 4. From where to where? From 0 to t. That will be what? Limit t goes to infinity. Minus 1 over 20. 5t plus 1 to the power 4. Minus 1. Take x equals 0. I have 1 to the power 4, which is 1 minus 1 over 20. Now this limit, as t goes to infinity, so I have infinity in the denominator. That will be 1 over infinity. That will be 0 plus 1 over 20. And the answer is 1 over 20. Converges to 1 over 20. Okay. This improper integral, the same idea. Yeah. I have problem with what? With the 0. So I have infinite discontinuity. Infinite discontinuity at x equals 0. So this one will be limit. Actually, you can't prove this. T goes to 0 from right. Integral t to 1 ln x over square root of x dx. Yeah, this integral, it needs some work. Yeah, it will be x to the power minus half ln x dx. Okay, it will be done using what? Integration by parts. Very clear. It should be integration by parts. So I have u is ln x, dv is x minus half dx. So what is v? It's 2x to the power half. I add 1, I divide by half. And du equal dx over x. That give me what? 2x to the power half ln x minus 2 integral x half times x to the power minus 1, x is minus half dx. And that plus, and that will be 2x to the power half ln x minus 2. What's the derivative of, what's the integral of x to the power minus half? It will be 2x to the power half plus c. So my answer, 2x to the power half ln x minus 4x to the power half plus c. Okay, let me plug this here. So I have limit t goes to 0 from right of what? 2x to the power half ln x minus 4x to the power half, and that from t to 1. Okay, let me do the calculation. That would be limit t goes to 0 from right of what? The 1, it will be ln 1, 0 times 2, which is 0. So it's minus 4 minus, now I apply the t. I have 2t to the power half ln t plus 4 t to the power half. I have no problem with this one. As t goes to 0, this one will go to 0. This one, I need the find the limit. I need Limiter's rule. Yes. So let me write it here. Let me take this space for it. I think it's enough space. So I have limit. I need to do this limit. T goes to 0 from right of t to the power half, then t, which is 0 times infinity. So this one I can rewrite it. T goes to 0 from right, then t over t to the power minus half. Use Limiter's rule now. I'm getting what t goes to 0 from right. I have infinity for infinity, yeah? Category. So I have 1 over t. And this one is what? Minus half t to the power minus 3 over 2. So that gives me what? That will go up. That will be t. 2 also will go up. So I have minus 2 limit. T goes to 0 from right. Minus 2 t to the power half. Yeah. This one will go as a power. T to the power 3 over 2 over t. That will be t to the power half. And that will be 0. So all of this is 0. So this limit is minus 4 minus 0. This is also 0. So the answer is minus 4. So it converges to minus 4. Okay. This improper integral. We have a problem. This is what? This is x plus 2 times x plus 1. Okay. So I don't have problem with minus 2, minus 1. They are not in this interval. So I'm concerned only about the infinity. So this integral will be limit t goes to infinity 0 to t dx over x plus 2 times x plus 1. Now, how to do this integral? I need integration by partial fraction. So as I said, you need to remember the integration methods. This will be what? A over x plus 2 plus b over x plus 1, b over x plus 1 dx. What will be a? We'll use the cover method. This is minus 2. So I have minus 1. Okay. Now we'll do it with the other one. Use minus 1. That will be 1. Check. That is minus x plus 1 plus x plus 2. That will be 1. Yes. So I have actually minus ln x plus 2 plus ln x plus 1. So that is what? Ln plus c. Huh? That will be ln x plus 1 over x plus 2 plus c. Okay. So that will be ln. Don't forget the limit first. Limit t goes to infinity. Ln of what? X plus 1 over x plus 2 from 0 to t. That will be limit t goes to infinity. Ln t plus 1 or t plus 2 minus 0. I have ln 2. Minus ln half, sorry. It's not ln 2. Minus ln half. Yes. Now this limit, I need to do it here. As I said, it's integration problem and limit problem. Sometimes you need to remember what we did. What shall we do with this limit problem? This is just a limit problem. Ln of t plus 1 over t plus 2. I know ln is a continuous function, so I can take limit inside and also the absolute value. So I have limit, absolute value, limit t goes to infinity, t plus 1 over t plus 2. This limit is what? Same degree, just the coefficient. So I have len 1, which is 0. So this is 0 minus len half. But len half is 2 to the power minus 1. So that will be len 2. And this is the conversion to len 2. This one, I have problem only with the 6. So I think this one would be an easy one. Limit t goes to 6 from right, t to 8, or I have infinite discontinuity at 6, infinite discontinuity at x equals 6. Okay. So I have what, 4, x minus 6. Let me write it this way. 4 x minus 6 to the power minus 3 dx. Yeah, that is easy one, easy integral. Limit t goes to 6 from right of what? You add 1, divide by that, 4 over minus 2, x minus 6 to the power minus 2 from t to 8. That will be what's minus 2. No, don't forget the limit. Limit as t goes to 6 from right of what? Of minus 2. 8 minus 6 is 2 to the power minus 2 plus 2 t minus 6 to the power minus 2. Let me do it in steps. That will be limit t goes to 6 from right. That will be what? 1 over 4, so it's minus half plus 2 over t minus 6 all square. Now, as t goes to 6 from right, what will happen to t? 1 over 2t minus 6 square. That will be 1 over 0 plus, that will go to plus infinity. From the graph also, you can see it from the graph. This is at 6. I have this goes like this, and it's this one, same go. So as t goes to 6 from right, this goes to what? Plus infinity. So I have minus half plus infinity. That gives me infinity. So I diverges to plus infinity. This improper integral. I have problem with the 5, where I have infinite discontinuity. Infinite discontinuity at x equal 5. So this one would be limit. T goes to 5 from left. 0 to t. 5 minus x to the power minus 1 over 3 dx. Do the integration. That will be limit. T goes to 5 from left. Yeah, you need to worry about this. There is a minus sign here. So it is what? Yeah, I can do it in steps. Let me do the integration here. 5 minus x to the power minus 1 over 3 dx. I let u equal 5 minus x. du will be minus dx. So I have minus and minus. So that will be minus integral u to the power minus 1 over 3 du. That give me what? Minus, add 1. 1, that will be 2 over 3. So it's minus 3 over 2. 3 over 2. U to the power 3 over 2 plus c. And that give me minus 3 over 2. 5 minus x to the power 3 over 2 plus c. So this is the integral. I'll write it here. Minus 3 over 2. 5 minus x to the power 3 over 2 from 0 to t. That will be limit. T goes to 5 from left. Substitute. What you will get? Minus 3 over 2. 5 minus t to the power 3 over 2 minus. This one is what? Minus 3 over 2. X equals 0. That will be 5 to the power 3 over 2. Substitute 5. 5 minus 5 is 0. So that will be 0 plus 3 over 2. It's 2 over 3. This is 2 over 3. This is 2 over 3. Yeah, add 1 to minus 1 over 3. That will be 3 over 2 over 3. That will be what? 25 cube root of 25. And the answer is this. Yeah. So this is convergent. Its value is this. This improper integral. We have problem with what? E have no problem. Infinite discontinuity at 0 and at 1. But E is more than that. So I'm concerned only about the infinity. I'm concerned only about the infinity. Yeah. This one, if it is 0, then x equals 0. This is 1. But I'm starting from E. So we have no problems. So I'm concerned only about the infinity. So I have limit t goes to infinity. E to the power t 1 over x ln x squared dx. How to do that? Let me do the integral. It means a little bit of work. It's not difficult. I will let u equal ln x du is equal dx over x. So that will be what? Integral du over u square. In other words, us minus 2 du. That will be minus us minus 1 plus c, which is minus 1 over x plus c. Okay, so this one will be limit t goes to infinity minus 1 over ln x from e to t. That will be limit t goes to infinity. Substitute 1 over ln t minus 1 over 1. Yeah, ln e is 1. Okay, so that will be limit t goes to infinity minus 1 over ln t plus 1. Now, as t goes to infinity, ln t goes to what? Also infinity. So minus 1 over ln t will go to what? Will go to 0. So this will be 0 plus 1, which is 1. So convergent, its value is 1. This improper integral, we have problem at what? Here I have 0, I have no problem because the interval is from 1 to infinity. So 0 is not a concern. Only my concern is about the infinity. So this one will be limit t goes to infinity, integral 1 to t, e minus square root of x over square root of x dx. Let me do the integration here. It's not that difficult, but just to relax it, I let u equal minus square root of x. So du will be what? Minus 1 over 2 square root of x dx. So I need 2 and minus 2 outside. Yeah, that will be what? So this will be du. I have minus e to the power u du. That will be minus 2 eu plus c. What is eu? That will be minus 2 eu is minus the square root of x plus c. Plug it here. You have limit t goes to infinity of what? Of minus 2 e minus square root of x from 1 to t. That will be limit t goes to infinity of what? Yeah. Minus 2 e minus square root of t minus 2 e to the power minus 1. Okay, now t goes to infinity. Minus square root of t will goes to minus infinity. So e is minus square root of t. I know e is minus infinity. That will go to 0. So all of this is 0. This minus, that will be plus 2 over e. And that will be 2 over e. And that's my answer. This improper integral. I have a problem with the 0. So you have infinite discontinuity. Infinite discontinuity. at x equals 0. Let me see what will happen. So I need to write limit t goes to 0 from left minus 1 to t a1 over x cubed dx. This integral is a little bit complicated. Not that complicated. It will be okay. I make this x squared times x dx. Why? Because if I let u equal 1 over x, du will be minus 1 over x squared dx. So I need minus and minus outside. So this is will be my du. So I need x. X will be what? Or 1 over x is u. So that will be minus 1 over x, which is u, e to the power 1 over x, e to the power u du. To do that, I need integration by parts. And also I know it. It's what? U EU minus EU. Is it? Check. I have EU plus U EU minus EU. Yes, that will be correct. Plus C. So actually it is e to the power 1 over x minus 1 over x e to the power 1 over x plus C. Plug it here. I have limit t goes to 0 from left of what? Be careful now. This is e 1 over x minus 1 over x e to the power 1 over x. This is from where to where? From minus 1 to t. That will be limit t goes to 0 from left e to the power 1 over t minus e to the power 1 over t over x over t minus have what here? E is minus 1 minus that will be plus e is minus 1. Now be careful. Yeah. So I have first I need to check 1 over 1 over t. That is 1 over t. So as t goes to 0 from left, I'm going to what? Minus infinity. So t goes to 0 from left, 1 over t goes to minus infinity. So e was 1 over t. This is goes to 0. I'm gone with this one. The other one, I need Lewis rule. Yes, because if I substitute, I'm getting 0 over 0. So I need a space for this. Let me take this space. So I have limit t goes to 0 from left is 1 over t over t. And this is 0 over 0. It's 0 over 0. So I need the Lewis rule. That will be limit t goes to 0 from right. That will be what? E to the power 1 over t times minus 1 over t square over 1. We substitute 0 from left. If I substitute, I'm still getting 0 over 0. That will not help. Yeah, if I substitute, I'll get what? 0 over 0. Still. Then if I do it again, yeah, that will not help. So let's think about a different way to do it. I need to do this limit. Yeah. Another way to do it, I can think of this as limit t goes to 0 from left. This t, I can make it 1 over t here. And I have e is minus 1 over t here. Now if I substitute, I'm getting infinity over infinity. Okay. Now let me do the L'Hopital. I have what? Infinity over. Now if I substitute 0, I have infinity or minus infinity. Who cares? And this is I have infinity. I have infinity over infinity. So I can apply L'Hopital's rule. Let me see what will happen in this case. T goes to 0 from left. I have what? Minus 1 over t square over. This one is what? E is minus 1 over t. Derivative of this, which is 1 over t square. That will do it. This one will be cancelled. And I'm getting what? I'm getting e to the power infinity here. So that will be limit at t goes to 0 from left. Minus e to the power 1 over t. And that will be, as t goes to 0 from left, 1 over t goes to minus infinity. So is minus infinity, that will be 0. That will be 0. Yeah. Sometimes you need to be careful with the limit. So that will be 0 minus 0 minus 2e. Minus 2e is minus 1, which is minus 2 over e. That's the answer. Yeah, be careful with the calculation. Limits problem. Okay. Now, let me check this one. I have problem with the 0, for sure. Then this is when it is x plus 2 minus 2. I don't care about minus 2. So I have only the 0. So that will be limit. T goes to 0 from right. I have infinite discontinuity at 0. Infinite discontinuity at x equals 0. I like to see. So it's type 2. Yeah, usually I write this. I have infinite discontinuity. Yeah, when you have infinite discontinuity, usually I write it. Okay, that's good. So integral 0 t to 1, since I changed this, t to 1, x plus 1 over square root x square plus 2x dx. Yeah, let me do the integration here. It's not a difficult integration, by the way. It will be square root x square plus 2x dx. So I let u to be x square plus 2x. Du will be what? 2x plus 2, which is 2x plus 1. So I need 2 here and half outside. So that will be half what? Du over square root of u. In other words, it will be half u to the power minus half du. And this is we did it before. It is 2 u to the power half plus c. So my answer is u to the power half plus c, and that is square root x squared plus 2x plus c. So this is my answer. So this will be the answer for the integration. Now the remaining is the limit after I do the substitution. That will be what? Limit t goes to 0 from right. Substitute the one. I have square root of 3 minus square root t square. Yeah, t square plus 2t. This is 0. Square root of 0 is 0. So I have square root of 3 minus 0, which is square root of 3. And this is my answer. Improper integral. I have problem just with the minus infinity. That will be limit. T goes to minus infinity. T to 0. X e for x dx. How to do this integral? Yeah, it's clear. I mean, it's integration by parts. Clearly, it's integration by parts. So let me do it here. I need to have space here. I need the tabular, I think. Yeah, the tabular will do it. X10 e for x 1 over 4 e for x 1 over 16 for x. That will be plus. That will be minus. So we have what? We have 1 over 4 x e for x. Yeah. Minus 1 over 16 e for x plus c. So this one will be limit t goes to minus infinity of what? 1 over 4 x e for x minus 1 over 16 e for x from where to where? From t to 0. Apply the 0. You have what? Don't forget the limit. If you apply the 0, you have this is 0. This is minus 1 over 16 minus, apply the t, 1 over t, e for t, minus 1 over 16, e for t. If you have minus infinity, yeah, this is 0 times infinity. Be careful. This is 0. This goes to 0, very clear. And if t goes to minus infinity, e to the power 4t will go to 0. I know it from the exponential function. This is the exponential function. So as t goes to minus infinity, I'm going to 0. Yeah, y goes to 0. Now this one, I need L'Hopital's rule. So I need the limit as t goes to minus infinity, t e for t. I have what? If you apply it, we have infinity times 0. Yeah, this is 0. This is infinity. Infinite minus infinity, infinity, who cares? Okay, so this is will be limit. T goes to minus infinity. I make it t over e minus 4t. So I have now what? Infinity over infinity, or minus infinity over infinity. Apply L'Hopital's rule. That'll give me what? 1 over minus 4 e minus 4t. Now it's 1 over infinity. Since this is goes to infinity, use minus 4t, it will go to infinity as t goes to minus infinity. Yeah, be careful. T goes to minus infinity. So minus 4t goes to infinity. What is e to minus 4t will go to infinity. Because I'm going to the infinity side for the exponential, that will go to infinity. 1 over infinity, that will be 0. So this is 0 also. So I have what? Minus 1 over 16 minus 0 plus 0. That will be minus 1 over 16. And this is converges to minus 1 over 16. This one, my problem is what with the 1? Yeah, I have infinite discontinuity at 1. Infinite discontinuity at x equal 1. So that will be what? Limit t goes to 1 from left, 0 to t, sine inverse over square root 1 minus x squared dx. Let me do the integration here. It needs some calculation. Yeah, I need u to be sine inverse of x. What will be du? Du will be 1 over square root 1 minus x squared dx. So this is my du. So I have u du, which is u squared over 2 plus c, which is sine inverse of x all squared over 2 plus c. So this integral will be limit t goes to 1 from left of what? Of half sine inverse x all square from 0 to t. That will be limit t goes to 1 from left of what? Half, yeah, sine inverse of t square minus sine inverse of 0, 0, 0 squared. That will be 0. Now limit as t goes 1 from left, t goes to 1 from left, sine inverse of t goes to what? Pi over 2. So this will be half pi over 2 square. That will be pi squared over 8. And this is my answer. Okay. Let me do more. This one. What's my problem? My problem, infinite discontinuity at 1, infinite discontinuity at x equal 1. So I need to split this integral 0 to 1 plus 1 to 3. Let me do 0 to 1. If one of them is divergent, that's it. Then this improper integral, all of it diverge. Okay, so I have what? This one, my problem with the one. So we'll have limit t goes to 1 from left, 0 to t, dx over x minus 1. That will be limit t goes to 1 from left. What's this integral? Len x minus 1. And I want it from where to where? From 0 to t. So I have limit t goes to 1 from left, len t minus 1 minus len 1, which is 0. So what is this integral or this limit? 1 from left is 0. I have minus infinity. So it's divergent. Diverges. That implies this limit or this integral, I mean, diverges. No need to check the other. This one, I think the same idea. My problem is what? When x equal 2 over 3. Not 3, but 2 over 3. Okay, so this integral will make it 0 to 2 over 3. 1 over 2 minus 3x dx plus 2 over 3 to 2 dx over 2 minus 3x dx. Let me take the first one, the first integral. Let me do this. Yeah, this one will be what? Limit t goes to 2 over 3 from left. Yeah, 0 to t dx over 2 minus 3x. Yeah, I can do this. Let u equal 2 minus 3x. du will be what? Minus 3 dx. So I need minus 3 and minus 1 over 3 here. I can do it in one step. T goes to 2 over 3 from left. I have what? Minus 1 over 3. This will be what? Integral. You know what? Let me do this integration aside. Better. 0 to t dx over 2 minus 3x. This integration, let me do it here instead of mixing the things. Dx over 2 minus 3x. I let u 2 minus 3x. du is minus 3 dx. So I need minus 3 and minus 1 over 3. So it's minus 1 over 3 du over u. Correct? That will be minus 1 over 3 ln absolute value of u plus c, which is minus 1 over 3 ln, what is it? 2 minus 3x plus c. So this will be limit this over 3 from left. Yeah, that make a difference. Minus 1 over 3 ln 2 minus 3x from 0 to t. That will be limit t goes to 2 over 3 from left of what? Minus 1 over 3 ln what? 2 minus 3t plus 1 over 3 ln 2. Yeah, problem is here. When I substitute this, I have what? 2 over 3, that will be 2 ln 0, which is minus infinity. So that will be minus 1 over 3 times minus infinity. That will be infinity plus 1 over 3 ln 2, which is infinity. So it diverges. So the limit integral, this integral diverges. So all of this diverges. Let me do this one, then I will stop. I have problem just with minus infinity. So I have limit t goes to minus infinity of t to the power 0 10 to the power x dx. That is what? What's this integral? Easy one. That will be 10 to the power x over ln 10. From where to where? From t to 0. Substitute, have limit t goes to minus infinity. 10 to the power 0 is 1, so I have 1 over ln 10 minus 10 to the power t over ln t. I know as t goes to minus infinity, it's like the e. 10 to the power minus infinity, that will go to 0. So I have 1 over ln 10 minus 0. So it's 1 over ln 10. And this is my answer. This one is easy. Let me do it quickly. This is infinity, my problem just with the infinity. This never 0. Limit t goes to infinity. 2 to t dx over 4 plus x squared dx. That's it. That will be limit t goes to infinity. What's this integral? It's 1 over 2. This is 2 square. Tan inverse x over 2. From where to where? From 2 to t. Okay, that will be limit t goes to infinity of what? Be careful here now. Yeah. That will be half tan inverse of t over 2. T over 2. Okay. Minus half tan inverse of 1. Now let me do this one. Let me do it in steps. T goes to infinity. So t over 2 also goes to infinity. So tan inverse of t over 2, that goes to what? Pi over 2. Don't forget, this is tan inverse. This is pi over 2. This is minus pi over 2. This is my tan inverse. So as the argument goes to infinity, this goes to pi over 2. So I have what? Half pi over 2. Tan inverse of 1 is pi over 4. That gives me pi over 4 minus pi over 8. This one is what? 2 pi over 8 minus pi over 8. That gives me pi over 8. So let's compare this to pi over 8. Yeah, I think we did a good number of questions. Let me stop the recording. Yeah. Thank you.